you'll have periplasmic extract from your bacterial cells. This should have protein in the solution. Among the proteins should be the beta-lactamase. So we need to do two tests on the periplasmic extract. One is specific for beta-lactamase. That's called an enzyme assay, an activity assay. And the second is to determine how much total protein is here. There are a mixture of proteins in this sample. We need to know how much total protein is in there. We will be using what's called a Bradford protein assay. You've been given this protein reagent, which has dye in it. It's Comasi Brilliant Blue G. And that dye will become more blue when it binds to protein. On the left is the protein reagent without any protein added. On the right has some protein added, and you can see that the dye becomes more blue. When you assay your periplasmic extract, I recommend you use 50 or 100 microliters of the extract. The protein concentration will be relatively low. So try first with 50 microliters and see if you get a blue color. By itself, the blue color is not all that useful. It will tell you, yes, there is protein present, but it doesn't tell you how much. One step to making sense of your data will be to measure the color in a spectrophotometer. This will give you an actual number instead of just saying it looks blue. The second thing we'll need is a gradient of protein from very low to reasonably high, and that will give us a standard by which we can measure an unknown color. So this is called a standard curve. You'll use a protein called bovine serum albumin, abbreviated BSA, and that will enable you to make a standard curve. Following the instructions in the Bradford paper, you should be able to make a lineup of tubes like this with increasing quantities of protein, getting an increasing gradient of blue color, which we measure in the spectrophotometer, and once we have this standard curve, we can match an unknown concentration to that degree of blueness. When you make your standard curve, you're hoping for a linear relationship between the absorbance at 595 nanometers and the micrograms of protein. And what's really important is what's the slope of the line. Once you have this curve, if you know any absorbance from your periplasmic extract, you can easily correlate it to the quantity of protein present.